Hi-ho, Tutorinos, it's Tutor Pat with 4 ways to solve a quadratic, possibly my favorite quick hit of all, certainly one of the most crucial, critical skills you'll need for success in the SAT, the ACT, and perhaps, let's say it, life. All right, so let's get cracking. What is a quadratic? Well, you probably know at this point, but it's always worthwhile to discuss. A quadratic is a function where the highest power of x is 2. This is written in what we call the standard form. And we kind of notice just looking at it that we have 3 crucial coefficients, which are going to be our friends throughout this mini lecture, a, b, and c. Okay? What does it mean to solve a quadratic? Well, this is a little bit confusing or complicated by the fact that the test makers keep phrasing this in slightly different ways. Solving is the same as finding the zeros, which is the same as finding the x-intercepts, which is the same as finding the roots. All it means is when I'm portraying this quadratic graphically, the solutions or the x-intercepts or the roots are those 2 places, or 1 place, or in some cases no place, where the x intercepts or goes through the x-axis, the horizontal axis. So again, to be super clear, when I solve a quadratic, also sometimes known as finding the zeros, finding the x-intercepts, or finding the roots, what am I doing? I am locating those places where the parabola, which is what a quadratic graphs as, intercepts or goes through the x-axis. That is all I am doing. Okay, and there's 4 major ways to do that. Let's talk about them. The first way, the easiest way, is factoring the c coefficient. So, again, as a reminder from just 2 seconds ago, quadratics are most often written in the standard form where I have 3 crucial coefficients, the a, the b, and the c. To more specifically illustrate this, I'll give an example. So let's have a nice little quadratic here. X squared plus 7x plus 10 equals 0. Well, we can already pretty much derive that my a coefficient is 1 because there isn't anything there, so we can assume it's 1. My b coefficient is 7, and my c coefficient, hey-oh, is 10. So how do I solve this, meaning find the intercepts, the x-intercepts of the parabola using the factoring the c coefficient method? Super easy. I'm going to look for 2 numbers that multiply to the c coefficient but add to the b coefficient. So they multiply to c, but they add to b. So I'm going to look at the factors of 10, which are 1 and 10, 2 and 5, and see if any of those numbers add to 7. And hello, sir, 2 plus 5 does add to 7. So I know that this is going to be x plus 2 times the quantity x plus 5. Those are the factors of the quadratic. Now, because they're being multiplied, and because they equal to 0, remember, whenever I have 2 numbers and they multiply to 0, that means one or both has to be equal to 0. So now that I know that this is one of my factors, this is the other one of the factors, I can set them equal to 0. I can say x plus 2 equals 0, or x plus 5 equals 0, x equals negative 2, or x equals negative 5. Again, what this means for this particular quadratic, this handsome little quadratic here, x squared plus 7x plus 10, my intercepts of the parabola it makes will fall at negative 2 and negative 5. So if we're looking at this example, it would look, the quadratic would look something like this. And my answers, my solutions, would be at negative 2 and negative 5. Nifty. So that's what we found, and we use it through the factoring the c coefficient method. A find method, especially if I have a simpler order quadratic, something with a nice, easy, factorable c coefficient where I can kind of run through the factors in my head, boom, 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 and see which of those adds up to my b coefficient. Now, unfortunately, sometimes it isn't that easy. Sometimes I got a really gnarly c coefficient, a big big ugly number that doesn't immediately factor. So I have another strategy, and that is the quadratic formula, or as we like in the business like to call it, the quad form. Now, even though the quad form is used for when I have really gnarly numbers in my A, B, and C coefficients, I'm gonna stick with my example just for consistency's sake. And I'm going to just run down, in case we forgot from a second ago, what my coefficients are. My first coefficient, my A coefficient, is 1. My B coefficient is 7. And my C coefficient, that devil, he's 10. Now, I'm going to plug these coefficients into the quadratic formula, which is this marvelous mathematical machine that through chugging and plugging will spit out, ding, the right x-axis answers. So, what is the quadratic formula? Well, if you're a student of mine, you probably have it programmed or downloaded into your calculator. But even if you have that, you really should have it memorized, especially my SAT students, because you're going to have 20 questions at the beginning of the math section you won't be able to have access to your calculator for. But even more importantly for my ACT students, for all students, you need to have it top of mind. It should be at your disposal. So what is the quadratic formula? It is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over the quantity 2a. Okay, so that's the opposite of the b coefficient plus or minus the square root of the b coefficient squared minus 4 times the a coefficient times the c coefficient, all of that divided by 2 times the a coefficient. So again, it's just plug and play at this point. I'm going to plug these coefficients, beep, beep, boop, into the corresponding spaces and simplify, and it will solve. Let's see. So that's going to be x equals opposite of 7 plus or minus this 7 squared minus 4 times 1 times 10 all over 2 times 1. Again, you see me just plugging in the relevant coefficients to where they go in the equation. Now I'll simplify it a bit. So that's going to be the opposite of 7 plus or minus 49 minus 40 divided by 2. 49 is 7 squared, and 4 times 1 times 10 is 40. 2 times 1 is 2. I don't know why I wrote 20. Zip, zip, zip. I can further simplify it down to the opposite of 7 plus or minus rad 9, because 49 minus 40 is 9, all over 2. Can further simplify that, and that comes opposite of 7 plus or minus 3, because rad 9 is equal to 3, over 2. Now, whenever I have a plus or minus, I like to break that out so I can see both scenarios clearly. So that means it would be negative 7 plus 3 over 2, and negative 7 minus 3 over 2. When it's plus 3, that becomes negative 4 over 2, and negative 4 over 2 is equal to, drum roll, negative 2. Now, when it's negative 3 or minus 3 here, that's going to become negative 10, negative 10 over 2, which, drum roll, is going to be negative 5. And we see that marvelous machine, the quadratic formula, spit out negative 2 and negative 5, which are the same negative 2, negative 5 we got through factoring the c coefficient. So another totally valid, wonderful way, especially if it's pre-programmed in your calculator, to get to the roots/solution/x-intercepts of a quadratic. But it is not the only way. There is yet another way. And that way, my friend, is called completing the square. Now, I have an entire other quick hit video about completing the square, which I urge you to watch. It's absolutely fantastic. But I think just for completion's sake, I'll go through the completing the square again here. So again, here I'm going to use as my example problem, x squared plus 7x plus 10, where my a coefficient is 1, my b coefficient is 7, my c coefficient is 10. The first thing I need to do when I'm completing the squares, I need to make sure my a coefficient is equal to 1, okay? So make sure my a coefficient is equal to 1, and I have fulfilled that requirement. The second thing I need to do is move the c coefficient over to the other side. All right, so let's do that. That's going to be x squared plus 7x space equals negative 10 space. Third step is I need to take 1/2 of the b coefficient, square it. All right, so my b coefficient is this handsome fellow here, the 7. Half of 7 is 3.5. Well, so 7 halved is equal to 3.5. And then 3.5 squared is equal to 12.25. Now the fourth step is to add that number, that 12.25 number, that number to both sides. So I'm going to take that 12.25, I'm going to add it to both sides. So that's going to be x squared plus 7x plus 12.25 equals negative 10 plus 12.25. My fifth step is to rewrite the left side of the equation as a perfect square. All right, what does that mean? Well, if I look here at the left side of the equation, I notice that the factors of 12.25, I can think of two numbers that multiply to 12.25 and add to 7. Why can I think of them? Well, because I discovered them over here, right? I can write this as x plus 3.5 times the quantity x plus 3.5. Right? It's a perfect square because those two numbers multiply to 12.25 but add to 7. So I can rewrite the left as a perfect square, as x plus 3.5 squared equals negative 10 plus 12.25, which I could simplify as 2.25. Now, the sixth step is I square root both sides. So we're running out of room because we're having so much fun. So I'm gonna copy this. Give myself another page here, paste it down. So I'm going to take the square root of both sides here, zip and zip. Well, the square root of the quantity x plus 3.5 is simply x plus 3.5, right, because it's a perfect square. And the square root of 2.25 is plus or minus 1.5. 1.5 times 1.5 is 2.25. Now notice, when I take the square root of a quantity, meaning something in parentheses, I don't put plus or minus, but when I have it as a plain value there, I do have to put the plus or minus. So now, as I said before, when I have these plus or minuses, I love to write it out both ways so I can see each scenario very clearly. So that's going to be x plus 3.5 equals positive 1.5, and x plus 3.5 equals negative 1.5. Now I'm going to simplify. So when I subtract negative 3.5 from both, I'm going to get negative 2 here, and I'm going to get negative 5 there. Hey-o. Hey, stranger. Negative 2, negative 5. So that's how I can use completing the square in these fun steps here. To get to those same answers. Now, truth be told, I don't usually use completing the square to find the roots of a quadratic, to solve a quadratic. I usually use it to get it into vertex form, which you can see more about in the other quick hit video, but I want to be a completist. Now, what's the final way? Well, the final way is use your calculator, right? You can graph it. You can go into your y-plot, your y equals button, if you're using a TI 83, 84, 84 plus CE, or you can go into your TI Inspire, right? And you can go into your Sketchpad and graph it, right? And when you look at the graph, it'll look something akin to this. And you can either use the trace feature to move your spider down to the intercept, and then you can zoom to see where those are, or you can hit the second plus graph feature if you're on the TI-84. That's going to give you the table of values. And you can look and see where y equals 0 and see the two places where the x values are. So, in summary, there are 4 ways you can factor a quadratic, or not factor, solve a quadratic. You can use it by factoring the c coefficient, when the c coefficient is a nice, easy number that breaks down into nice, clean integer factors. But if that's not the case, you can use the quadratic formula, which you need to have memorized. It's the opposite b plus or minus square root of b squared minus 4ac all over 2a. Or you can complete the square, which is also a great strategy to find vertex form, but you can use completing the square to actually solve a quadratic. Or you can use your calculator. And you can use the graph functionality of either your TI-84 or TI-Nspire, and use the trace function to look at the intercept, move the spider down to where it crosses the x-axis. Or you could look at the graph, the table function by hitting second graph, and look to where the y's are equal to 0 and see what the x is equal. So those are 4 great strategies to solve a quadratic. And both the SAT and the ACT is very interested in seeing if you know all 4. All right. See you next time.